Let's take a look at parallel and perpendicular lines. So now in this packet, it is page 33. We represent parallel lines with these two diagonal lines. And they kind of seem like they're never going to touch, right, if they go on forever. And then perpendicular lines is represented like an upside down T. Because with parallel lines, they never intersect, like never cross over. And then when we talk about perpendicular lines, it's two lines that intersect, unlike, parallel lines, to create 90-degree angles. Now, if you look at our little abbreviation for perpendicular, you could also use the abbreviation perp. You can actually see the perpendicular lines, like the 90-degree angles. You can see it right here, right? If I were to draw in those little boxes, and technically if that perpendicular line to the horizontal line kept going, you'd actually see more angles at the bottom. Now what we're going to focus on is looking at equations and seeing if they are parallel, if they're perpendicular to each other, right? But the first things first, we want to get all equations to the same format. So what we want to actually work with is slope-intercept form. We might use point-slope form, PSF, to get us there, but our final format, we want it in slope-intercept form, right? And just a refresher, that is y equals mx plus b. M being your slope, b being your y-intercept. All right, so let's take a look at this. It says determine which lines, if any, are parallel or perpendicular. Show your work. So with getting the equations to the same format, let's get them all to y equals. So let's add x. We get 3y equals x plus 1. Not done yet. Let's divide by 3. I get y equals 1/3 x, right, plus 1/3. I'm going to write that my slope is 1/3. All right, I'm going to highlight that. Okay, let's move on to the next one, right? We can't solve anything until all three of these lines, line A, line B, line C, are all in the same format. So this one is already in slope-intercept form. We don't need to do anything. We could actually immediately go ahead and write that our slope is -3. We can extract that information from there. Just going to highlight it. Now the other one. All right, subtract by 2x. We want to get this in slope-intercept format. I get -6y equals -2x plus 4. Let's divide by -6. So I get y equals positive 1/3 x minus 2/3. I got 2/3 because it should be 4/6, and then I simplified it. That means my slope is positive 1/3. So when you take a look at slope-intercept format, right, you have it in SIF. Now, if they have the same slope, it means that they're parallel to each other. That means those two equations are parallel to each other. So I actually have this one and this one. These two equations are parallel to each other. If it is the opposite reciprocal slope, then it means it's perpendicular. So let's compare these, right? We have m equals 1/3. Oops, let's just fix that up. Let's label this line A. M equals 1/3. Line B, m equals -3. And line C, m equals 1/3. We already determined that line A and line C are perpendicular to each other, right? So let's go ahead and write that. Line A and line C are parallel. Oh, I know I said perpendicular, sorry. Line A and line C are parallel. We know that because they're the same exact slope, right? But now, if we actually look at this, right? Let's take a look at 1/3 and -3. All right, perpendicular means opposite reciprocal. So let's take 1/3. What is the opposite of 1/3? -1/3, right? Okay, now let's take the reciprocal of -1/3. You get -3. That means these two are perpendicular to each other, as well as these two are perpendicular to each other. So how you would write that in your final answer on page 33, it's line A and line C are parallel. Then you'd also write lines A and C are perpendicular, right? You could also use a symbol, you could use abbreviations, to line B. And this would be your final answer, right? You could do all that math and write it out, but your final answer needs to be written in words because it's actually asking you to determine which ones are parallel, if they are, and which ones are perpendicular, if they are. So your notes are right here. You want to have all these notes right here. And here's an example that goes with it. All right, let's go to the next problem. Example 2 says write an equation in slope-intercept form of a line that passes through -2, 4 and is parallel to this equation. Okay, what I know about it being parallel is that it needs the same slope. So I can actually extract this slope and I can use this point. So right now I have a point and I have a slope. Can't you write that in PSF? Yeah, because you have a point and you have a slope. So let's do that. We get y minus 4 equals -3 times x plus 2, right? We put it in PSF. Now I can distribute everything and get it into slope-intercept form and get it into SIF. So I'm going to distribute. I get y minus 4 equals -3x minus 6. Get y isolated. And I get y equals -3x minus 2. That means this equation, y equals -3x minus 2, if we were to graph that along with the original equation we started with, y equals -3x plus 4, they would never touch. They would go on forever, never intersecting because they are parallel lines. I know, just remember the steps. It's a little tricky, but you'll get there. Let's try the next one. This is the only other one that you're going to try, okay? Now it says it wants it in slope-intercept form. It passes through this point. Okay, we have a point, but it wants it perpendicular to this. So we have a point, which is 4, -2. Our slope over here is 4, but remember, we want it perpendicular. So my regular slope is 4, and then my perpendicular slope, if I do the opposite reciprocal, opposite of 4 is -4, reciprocal is -1/4. Should be -1/4. I'm going to highlight again what I'm going to use because I have two slopes here, right? And I don't want to use the wrong one. I have this point, see this in yellow, and this slope. I want to use the perpendicular slope because the directions tell me I need a perpendicular equation. I have a point, I have a slope. Let me put it in PSF, right? Step 1, let's get into PSF. So we have y plus 2 equals -1/4 x minus 4. Step 2, get it into SIF. It might take a little while to get there, right? Because we have to distribute, we have to isolate y. That's fine. Take your steps and take your time doing so. Make sure you get those calculations right? -1/4 times -4 is a +1. Then I'm going to subtract 2 on both sides. Be careful when subtracting with integers. So this ends up being y equals -1/4 x minus 1. And that is our perpendicular line to the original problem. So let's just go over the steps real quick, right? step one is to figure out what do you have, right? Just like you did with all the other types of problems when turning it into standard form, slope-intercept points, whatever it is, right? What do I have? Step two, what do I need? So usually that step two question is usually what can I do, but we won't ask what do you need, right? Do you need a slope that is parallel, or do you need a slope that's perpendicular, right? You have to figure that out. What do you need? And then step three, you ask yourself, what can I do, right? Because now it's, all right, well, I have a point and I have a slope, so you're going to take PSF. Then step four, you're going to get it into SIF, and you have your new equation. Take your time with solving these problems. We're just going to look ahead at bottom of this. So again, you have a point for number one, you have a point, and you have a slope. And these directions tell you parallel, so you're going to stick with the same slope, right? You have a point, you're sticking with the same slope. Let's say you get an equation that's not in slope-intercept form, so you don't know what it is, right? If that's the case, like number four, you have a point. Oh no, you do not have a slope because this is not in point slope-intercept form, right? Solve it. Get it into slope-intercept form first. So if we subtract 6x on both sides, we get negative y equals negative 6x plus 1. Divide, we get y equals 6x minus 1. Now I have a slope to work with. Now I can go back to this step. All right, now that you have a slope to work with, what can I do? So this step two, what do I do for finding my slope? You might have to rearrange the equation. You might have to reconfigure the slope to find the perpendicular slope. You might have to take a few steps to get there. You have all of the pieces of the puzzle. You have all of the information. Now it's time to take that knowledge and connect everything and think about what else you can do to get to that final answer.